Hey everyone. Today's session is about understanding MCP, which is like a very common buzzword in today's generative AI landscape. So MCP stands for Model Context Protocol. Today we will see how to develop like an MCP server using Node.js, and we will also use AWS SDK, like Amazon Web Service SDK, to do certain tool operations using the MCP server. So in this tutorial, you will learn how to create an MCP server, run it on the local, same time access AWS resources. In our example, we will access AWS RDS services like Postgres database. We will do operations like creating the table, running SQL queries on top of it, and we will also create like a glue, which is nothing but Apache Spark code, and we will read from an RDS table right into another RDS table using a glue job. So this all happens within sitting on a chat screen, and we can just type in, and MCP take care of all this backend process behind the scenes. So I have like a couple of slides. After that, we will straight deep dive into the demo as well as the code used for the demo. So what is MCP? MCP is nothing but an open protocol developed by Anthropic, and this allows tools and models to share a structured context. Developed for use with foundation model like cloud, and Amazon Bedrock is another model hosting service, so which hosts like close to 108 models, and you can use a lot of these models which support tool use in the context of MCP. And MCP enables tool use, memory, conversational context, and structured reasoning. Why MCP matters? MCP is mainly used for invoking tools, for example, file search or database search, launching certain job, even infrastructure jobs, right? Like creating databases or creating um, anything on cloud provider, as long as there is an API access to it. It also make LLM aware of the context object, like LLMs are trained on certain data set, but if you want to bring more data, like today, one of the methodologies to have a RAG knowledge base. But if you don't want to use RAG pattern, instead of that, bring the data into the model and provide more context, then you can query the table on a live basis and bring the data. That is also possible using MCP. Another one is useful in chat agents like IDEs and custom AI assistant. It also enables like long-term memory and a reusable context. So without further ado, we'll just go into the use case itself. So basically, we are trying to create a Node.js app which will communicate with the Cloud Sonnet model, specifically via Amazon Bedrock Converse APIs. It also enable dynamic tool invocation. You will see in the demo how different tools are invoked and what is the reasoning behind it, and how the Bedrock and Cloud Sonnet work together with that reasoning logic to use what tool and when to use. It also inject context object like databases. So in the end-to-end demo, what we'll see is we'll create, read and write from AWS RDS table. We will also write a glue job, which will read from one table and write into another table. And I will show the detailed code how to get all this done. And the code is also shared. My GitHub repository is shared, so you can just clone the project and start working from there. So let's have a look at the flow, how it works. Once we run the server, we will be able to send user input. So user input is nothing but the prompt, which is a conversational text. In plain English, I will ask like, create a table, query this table, create a glue job. So it goes and understand the context. It goes and execute the corresponding tool behind the scene and do that operations. So in the flow, what happens is it sends the request directly to Bedrock. So Bedrock, again, we are using Cloud Sonnet in this as a LLM model. So Cloud Sonnet, what it does is it detects the context, it understands what tools need to be used, and it will come back saying that, hey, this is a tool I need to use to create a table. And the node.js function will handle that tool handler part that will go and execute that particular operation. And the query result and the tool result will be returned again to Amazon Bedrock. For example, if the what if the table already exists, then the tool will definitely error out, right? The tool will say that, hey, the table already exists. Then it goes back to Cloud Sonnet through the Bedrock Converse API, and these LLMs are smart enough, so they might recommend, hey, this table already exists, or do you want to create another table, or do you want to query the table? So that reasoning comes from the LLMs itself. And this goes back and forth, and model will continue with the reasoning. So here, in the context of this demo, I have put some stops, like don't use the tool too much, right? Maybe like repeat, like try to use 2 to 3 times, and after that stop it. So when we go through the code, you guys will understand that. Again, resources and next steps. So if you want to know a little bit more about MCP and MCP spec, these are the links. And if you want to know a little bit more about Amazon Bedrock and documentation, it's also available here. And the entire code is available in my GitHub repository. It's a public code, so you can clone and go from there. So without further ado, we'll just go into the code, and after that we'll see a brief demo. Okay, so let's have a look at the code itself. It's a simple Node.js code and a very simple code structure you can very easily follow. So as I mentioned, this code is available in my GitHub repository. You can just clone the code. I have put a brief README document over here how to do it. Once you clone the project, you can do npm install, and which will install all the dependencies and stuff. And after that, you should be able to run the server using like this node command. And there are two aspects to it. So I want to be very particular about that. So there are two aspects. One is we are hosting an MCP server, and one extra bonus thing I'm doing is I'm also exposing this MCP server through a REST API. So you don't need to create any MCP client or anything like that. So this is available via REST API. So if you want to make it like production version, probably you can have this running on a EC2 instance or a Docker container or something like that. And the MCP endpoints are available using a REST API. So there is also a way to do HTTP streamable interfaces using MCP client. So I kind of bypassed that step because I wanted to build a lot more on top of this, not just MCP. So, for example, if you want a front end Angular or something like that, I want more REST API endpoint. So I want to have like our MCP client wrapped on a REST endpoint. So it's pretty simple. Once you have this REST endpoint, you can call this REST endpoint using your Postman or any other applications which can send post messages, right? So and again put a request body like how it accepts a JSON message in this format, and it will go and execute. So I will also show another way of running this. For example, you don't want to have a REST server, you just want to run this MCP server using MCP client or using Cloud Desktop or Visual Studio Code. That is also possible. So in this demo, I will also show show how to use the same tool using Cloud Desktop as well. So here we don't need to create two different things. Everything is already available. So if you want to run a REST API, just go and run the server.js file using node command, and it will be available in localhost 8080. Or if you directly want to use in Cloud Desktop, I will show how to do that as well. So let's have a look at the code and code structure. So it's pretty straightforward. I have like CMZP, which is just a folder, right? And in the folder, I have this entire logic written. So this is where the tools are created. AWS tools are, MCP tools are created. And I have defined it in two different structure. As I mentioned, our tools are going to do bunch of RDS operation like creating the table, reading the table, writing the data into the table, also creating glue job, and you also will see some sample code how to work on an iceberg table as well. But I'm not going to go over that. But this code is available, so if you are building something with iceberg, you can directly use this code. So let's have a look at the code, right? So here is where I'm defining the tool handler. So tool handler is nothing but we name the tool and give a description what the tool does and what is the input that tool needs. So obviously this is a create table. Then the input needed is like the table name itself, right? And you also need the column name, data types of the column and such. So again, insert data, you need the table name and the insert object, right? Name of the columns and what kind of data. And querying table is pretty straightforward. You can select the table and only input it will need is the table name. And if you have any optional where clause, right? For example, where name equal to something or where country is equal to something like that, you need that conditional argument as well. And you will also see a create glue job over here, which is a Spark job. So we do a PySpark job, which mentions source, target, what kind of glue version. So a lot of the things are uh, you can accept as parameter from the user, or you can directly hard code into the code. That is also quite possible. So this is about tool handler definition. Now let's see actual implementation of the tool itself. And it's pretty straightforward. I'm using leveraging AWS SDK to do these operations, right? So if you're not familiar, just search about Google AWS SDK and what are some of these APIs available. It's basic. I will show one example, which is like create table, right? So create table, as you see in our tool, takes a couple of arguments, which is like table name and columns data type, right? So with that, we are executing a statement, like a create table statement, just like how we will create the table manually, right? And into database, here I'm hard coding the database, but you can also maybe accept it as a user input. That also you can do. Once this is done, you are executing it on using your AWS SDK, RDS execute statement, and create table, whatever the script we formulated that is being passed. The same thing applicable to insert data and even querying the data, the same thing. So you, based on the query statement, like if there is a conditional argument, then you have this query. If you don't have it, just it's a straightforward select statement. Let's have a look at some of the configuration needed. So obviously you need AWS configuration. So this is where in the README I put some of the prerequisites are you need an AWS account for sure, and you need to have an IAM user. And here I'm passing my profile directly. Another way of using it is you can directly pass parameters like key credentials, right? Your AWS secret keys, and access keys, something like this you can do. That is also possible. But here, all of my credentials are wrapped inside a profile, and I'm directly using the profile file. Now, I also have a general configuration, right? It's pretty straightforward, like what RDS database we are talking about, where should the glue script go, what Athena S3 location. So basic locations. So you can put all the, once you have all these objects created in your AWS account, you can pass the AWS, the corresponding resource ARN over here. Okay, so now with that, let's have a look at server.js also. As I said, server.js is not doing much. It's basically creating like a chat endpoint. Behind the scene, what it does is it uses the MCP client. So you can see we are initializing the MCP client over here, right? And then we are creating a HTTP endpoint where you can communicate to. So once and this there are a bunch of things being handled. For example, you are using conversational API, so you want to continue the context of chat. So it cannot be like one request, create a table, and when you send the next request, it does not have a context about the previous one. So what we need to do is we need to keep a session, right? And in that particular session, we keep all the chat corresponding to that session, so that the models have a context like what this person is talking about, and we continue the conversation. There is a continuity to it. So all those are handled over here. It's simple. We are not using any database or anything or any memory cache or session cache to do it. We are just using like a um, JSON object, like a JSON file over here, and you can see how I'm keeping a session ID, right? We are keeping it in memory. So as long as the server is running and there is memory available, it's available. If you want to checkpoint into some database and some file, that is quite possible, but I haven't done anything like that. Let's have a look at some of the important aspect of the code, right? You can see I have set turns to 10, maximum tool turns to 7. The reason is Bedrock or Cloud Sonnet is going to bring back the response, and there will be a non-stop continuous thing happening, right? The table got created, then you query the table, and so this operation will continue. So unless we don't want that kind of continuity, we want it to follow it to do certain things. After that, stop the conversation, right? So if it goes to a infinite loop, this is how we are making sure it does not go to an infinite loop. So it takes turns only 10, and after that, it takes only tool turns 7. That's mean uh, here, at least in the context of this operation, 7 times tool use is absolutely enough, right? So whatever operation we're going to do, maximum 7 times. So you can increase that number based on how complex you're building that workflow. And you will see some bonus code over here because what I wanted to do was I wanted to have a chat GPT kind of interface, and how the chat GPT display the content, right? It shows in chunk. It doesn't wait for everything to get over. Instead of that, you get a feel of actually you are communicating or chatting with some person. So it have this concept of chunking. That's why I have implemented that over here. It's not very important to the demo as such, but if you are building a UI on top of it, it will look pretty cool, like how the conversation builds, and you have more follow up on top of that. Nothing much over here. I think only one important aspect I want to touch upon is we are using Bedrock APIs, right? So in AWS config, I wanted to show you that. You will see like S3, SDK endpoint, SNS we are not using. Again, RDS data service and Glue and Athena. These are the important thing. And you will definitely see Bedrock runtime because that's where our model is hosted. We are using a foundation model which is readily available. We are using Cloud Sonnet in this case, and what it does is this particular file defines all the runtimes and such, and we are using converse command. So there are multiple endpoints where we can use. Since this is of a communication nature or a conversation nature, we are using converse command. And you see the system prompt. I have a very simple system prompt. I'm saying that you're an assistant with access to various tools that can help solve the problem. Show the reasoning, like why you're choosing to do things certain way. And if there is a tool used, give me a response in JSON structure so that I can use that and use that particular thing and display it in a particular way in the front end. And all the reasoning, all the conversation show me in a HTML format, right? With proper tags and such. Then I know that if I'm displaying it in front end, I know if we are talking about like JavaScript code or Python code or Spark code or whatever it is, show me the language. So this prompt, system prompt, kind of set the input expectation as well as the output expectation. And after that, line 134, this is where we are making sure the code does not go into an infinite loop, like Bedrock is doing using some tool and tool is responding, and we continue the conversation. We don't want this to be going in a never-ending loop. So as long as the action is done, we are asking to stop and then wait for user's next instruction. And rest of the code is pretty straightforward, simple. Like if there is a tool used, make sure that tool count is getting incremented, and keep pushing this message, right? Keep pushing this message into an array, like whatever the communication happening back and forth, keep pushing into an array, so that Bedrock models have a context. It has the entire conversation with it. So nothing much to explain over here. At the end, when everything is done, we are sending that final message onto the front end, right, to the browser. So it will come in your response format. Um, Again, I have a endpoint, as I said, like just like ChatGPT, you want to have new conversation, you want to forget all the old conversation. I have an endpoint which will clear that particular session and erase everything from memory. Rest everything is some sort of utility function because Bedrock and will have throttling issues because if you're sending like after a lot of instruction to Bedrock, you will get throttling issue. In case of throttling, have like a dynamic delay, right? So these are the some of the utility functions. That's pretty much it. And you see here we are running this on localhost 8080. So with that, I will just show you how to run the code. Um, So you run node server.js. The code will start running. That means your endpoint is available on localhost 8080. You can also see at the beginning of the line MCP client connected successfully because we already done that. So we are wrapping our MCP client in a REST API endpoint. So that part is already being taken care of. Uh, so I will first show how to use this REST API. And I will now also show after that how to use this index.js file directly and make use of tools like Cloud Desktop. So let's go to Postman. I have a sample request over here. So I'm asking create a table MCP test. Let's do one thing. Create a table MCP test2 with column name, job data type, and use data type as like varchar 100. I'm going to hit the send button. And while this is working on, let's see the logs which is getting printed. That's very useful. So you can see the message is already passed to Bedrock. So I put some arrays and stuff so that you know like what message is being sent. So this is a simple message which we send, right? And the message is sending into Bedrock, create a table MCP test2, and it understand that we need to use the tool create table, right? So Bedrock realized that okay, this is a tool need to be used, and it also give the instructions like hey, this is how because we asked what is the reasoning. So it give you the reasoning like we use MCP test2 as the table name and data type and everything we already mentioned. So it just went and created name varchar 100 and job varchar 100. Both columns are set to varchar 100. So LLMs are smart enough to extract what exactly you want and pass that into MCP. So that's the advantage of using MCP because it kind of put into a protocol, it kind of put into a version where LLMs can communicate back and forth. And I also mentioned like since you're working on AWS, you also want to know about the pricing of different things you're doing. So I asked, hey, let's have the pricing information also into it. So it kind of LLM used its own data and said that okay, this particular operation will take so and so. And it also comes with a follow-up instruction, right? Do you want to insert data? Do you want to query data? So this operation is kind of done. So you can see I have pulled everything back, like including the tool use. So you can see the tool use was like create table and what parameters it required like columns, right? Like name and data type and such. And you can see this chat is continuing. The tool use requested is create table. It already sent. The tool use is complete. So finally, it is kind of summarizing everything back to us. So let's make sure that the table got created. So for that, what I'm going to do is instead of going to AWS console or anything, let's say insert sample rows to MCP test2. Let's see what it does, right? So we are inserting some sample rows to MCP2. So here LLM itself is gonna come up with some sample data, and we have a tool called insert data. So you can see, certainly I will help you to insert in terms of, however, before we proceed, I will make sure we have necessary table information. So here you see it's smart enough to go and query the table and make sure that all the it needs all the data which is needed, right? And insert the data. It needs all the data type and insert into it. So I think that here the tool use is insert into, and you can see that that already got executed. I'm going to give a little bit more sample data, like how the sample data should look. Okay. So here, if you see the tool, it has already detected what tool to use, and it says that I have inserted sample row into the table with provided information. Here is a breakdown of what was done. So you can see the table name is MCP test2 and it's all done. So I'm not going to AWS console to see that this got accomplished or not. Instead of that, let's use our MCP itself, right? And let's say query table sample MCP test2. Again, the same thing. Let's go to log and see. So it's querying the table MCP test2 and already Bedrock and Cloud Sonnet identified the tool need to be used. It's query table tool, and here are the result. Right, the table seems to have two column, and it gives you a summary. So let's go to our JSON output and see. Man, it's split. So let's see it here itself. So the table seems to have two columns. The first name column contains the value Hari. The second column consists value of software engineer. So you see the data is already there. So let's make sure. Let's go to the query editor tool and run this. So now let's do one thing. Let's go to AWS console and make sure whatever operations we did so far. We created a table called MCP test2 and uh, we inserted one sample row. Right, we can insert more sample rows, but for time being let's stick to the one row which we provided. So I have logged into AWS console and you can see that the table is already created. So let's start from MCP test2, which gives you uh, give the data. You can see the sample data is inserted. um, I can also insert more here, insert more sample rows. Sample rows. Let's be very specific, insert 10 sample rows. Yeah, so here you can see now it got an idea like what kind of tables. So it started inserting more record. Let's make sure that the data got inserted into the table. Yeah, so you can see more here, more sample rows got inserted. So this is cool. Now I want to show you how to use the same tool instead of exposing it to HTTP endpoint. Let's see how we can do this using Cloud Desktop as well. So before getting into the Cloud Desktop, uh, what we need to do is make sure the Cloud Desktop is available to access this tool. So there is a file called Cloud desktop config.json. This will be available in your app data roaming where the cloud is got installed. You'll see the cloud desktop.config.json. If the file is not available by default, just create with this name and restart the cloud desktop. It will automatically pick it up. So here you can see I am having two tools, right? One was like an OKX tool, which is another one, which is not relevant to this demo, and another one is MCP AWS. And the path, there is no server or anything, right? This is a path where that index.js file, which I showed you earlier. So not the HTTP endpoint, the server.js instead of the utility one, right? Index.js. You directly point it to over there and restart your cloud desktop. And what you will see over here is you will see the cloud tools. So this MCP AWS has 7 tools, right, which I showed you. As create table, insert data, query data, create glue job, create iceberg table, insert it to iceberg, query iceberg. So all these tools are available. So let's try to use, let's straight away ask the same thing. Query table MCP test 2. So this because Cloud want to be sure that these tools are like something you are accessing. I mean, it's something you are approving. So make sure that it always gives you this prompt. So this is a good fail-safe mechanism. For example, if you're creating something, you just want to make sure that give like another confirmation. This is good use. So I'm gonna say always allow because all the 6 tools I have tested it before. Okay, so now you can see what is the tool being used, right? And what is the query data is the tool, and the parameter passed is MCP test 2. And you can see it already queried the data and given you in a particular format. The same thing what we did in using the REST API endpoint. The output doesn't matter, doesn't change. It's basically the same thing. Invocation, same thing. It's 2 different tools. One we invoke through MCP through Cloud Desktop, and another one we just invoke the MCP client through like a REST API endpoint. You also see there are some suggestion. I notice Hari appear twice with different job. Let us know you would like to perform specific analysis or filtering on this data. So it continue the conversation, right? So with that, we are kind of done with the RDS part of it. Now I will quickly show how to create a glue job because we already created the tool. Let's see how MCP tools can go and create a glue job based on the instruction which you are giving in plain English. Okay, so for this part of the demo for creating the glue job, let's be we need to be very specific, saying that the processing has to be done using glue. Otherwise, what is going to happen is it might run some shortcut JavaScripts behind the scene and get the thing done. So this is a demo, but still assume that we are going to use glue, and we have like a lot of data, so we want to use like a distributed processing framework like glue to execute it. So I'm gonna use the same table, right? MCP test 2. We have some data sitting there already, and we're going to say create a target table, create a RDS target table, MCP test result with column name. Let's do this thing. Let's do some aggregation. Column job name and count of job name, and aggregate the job information from RDS table MCP test and insert into the new target table. So what we are trying to do is we already saw this data like Hari software engineer, Hari developer. So what we want to do is we want to see how many developers exist or how many QA engineers exist. So do an aggregation based on the job type, job type, and count and load into a new table. So this is a basic ETL which we do, right? So you can do complex things, but let's try this very basic aggregation. I'm going to send a message and let's see how it is getting processed. So here I'm using Cloud Desktop for all this thing. So you can see the reasoning, right? I will help you create new RDS table, MCP test result, that will store aggregated job information from the table MCP test to. Here is the plan. Create new table. So we already asked for the reasoning, so it's kind of going and telling me what's the reason behind. And you can see tools are getting executed already. So first it is going and creating the target table because it does not exist. Now it's querying the data so that you understand the data type and such. So it queried the data. Now I'll insert the aggregated data into new MCP test result. But you know what? We did not mention the glue job at all. So here I'm going to decline. So you can see behind the scene, it did some sort of Java operation, JavaScript operation, and created the count. Because the data set is very small, you don't need to have a glue or anything like that. So that is why it went and did that. So we need to be very specific here. So what we are trying to do is we will go and tell that do the same operation and this time use AWS Glue for processing. Decline. Use AWS Glue for data processing. So this time what is going to happen is because we already, as part of our previous instruction, it went and created the table. So already the table is existing. You see that it started erroring out, but it's okay. Our code is handling the error, right? So it kind of errored saying the table already exists. So you don't need to do it anymore, which is good, right? It's not stopping the job over there. Instead of it's continuing. Now here you can see it went and created the glue job and it did all the operations like aggregations. We wanted to aggregate by job name and count, and AWS glue job has been created and it got started also. So you can do more fun things like scheduling it and sending the report to your email. So it kind of I shouldn't be saying it, but it kind of reduce that development effort, right? Like as a business user, you can directly go and, as long as you know the table names and such, you can go and do your analysis. You can do and go and run your what processing you want to do directly using plain English and get that done. Okay, so you can see the create glue job. As you know, behind the scene, the glue job is going to be like a long running job, right? It might take 2 to 3 minutes. So we don't want to wait for that. So probably give the job ID. I'm going to decline all this thing, right? And let's stop this. You can see the create glue job, what it did. And this is a script it did. And after that, it went and inserted, went and ran the job. So now let's go to our AWS console and make sure that the glue job got created. So I'm on my AWS console again. I navigated to AWS Glue Studio and I want to see the job got created or not. So today is 5/5 and we are running. So there are two queries, right? Because I executed it twice. So let's go and see if the job got created. Yeah, you can see the job got created. And this is exactly what we wanted, right? We wanted like an aggregate operation group by column name and write output into this thing. So I have kind of replaced all this URLs and such. So if you want to give a connection parameter and all, it's quite possible. So you can pass it in your um, chat itself saying that hey, use this connection, or you can dynamically hard code that into your code based on the user or based on the project. So there are many ways to control this thing. So you can see the job got created and job ran also job ran. So I had to change these parameters to make the job run successfully. So thanks for watching the video. I hope you understood the concepts of MCP, how to create like a MCP server and a client using Node.js, and how to have a REST API around it, like a REST wrapper around it. You can also use tools like Cloud Desktop or VS Code to run the client as well. And again, as I mentioned, the next step, you can read about some of these concepts, read about MCP, read about Amazon Bedrock. And if you want access to this code is available over here. It's a public repository, so you should be able to check out and build on top of it. Thank you. Thanks for watching.